SPG podcast is brought to you by the Space Generation Advisory Council. SGAC is a global organization and network which aims to represent university students and young space professionals in the United Nations, space agencies, industry, and academia. Hi, welcome to the third episode of the Commercial Space Project Group podcast. I'm Kristine, and today we have a special guest, Glenn King, the director of NASTAR Center. Hi, Glenn. Welcome to the show.
Hi,
Um,
Kristine.
Thank you. Thank you for accepting our invite. So, to start, could you introduce yourself and share a bit about your background? And can you also give us an overview on what you do at the NASTAR Center?
Okay, yeah, I'd be very happy to do that. My name is Glenn King. I'm the COO and Director of Advanced Aviation and Commercial Space Flight Training here at the NASTAR Center. The NASTAR Center's been here for the last almost 20 years, and I started with our parent company, Environmental Tectonics Corporation, 35 years ago. And then about 20 years ago, was assigned to be the director of the NASTAR Center. And that assignment came about because of my background in aerospace physiology. I'm a pilot, skydiver, halo skydiver, scuba diver, do a lot of things in the physiology realm of things. So that was a perfect fit for me to lead up the NASTAR Center and provide training programs for anybody that's going to be going through an extreme environment. So we do high G pilot training here for military pilots. We do high altitude training for pilots and space astronauts. We do space flight training for commercial astronauts. Um, our space flight training programs, we started with Virgin Galactic many, many years ago when the Anusha Ansari X Prize was won by Burt Rutan and his team. As you know, Richard Branson bought into that technology and wanted to start a space tourism business, which became Virgin Galactic. So he did some research and found out that we weren't the NASTAR Center at the time, but we were Environmental Tectonics Corporation, and we provided high performance human centrifuge training to military pilots all around the world. Well,
Mhm.
he recognized that the dynamics of a commercial space flight, well, they're very dynamic, to say the least. So he thought that our people that enroll in our program were going to need space flight training. And he came to us saying, could we provide this? And looking at the flight situation of the flight dynamics of what the Spaceship One went through, said, yeah,
Mhm.
we could do this, but your people would need to be trained because this is nothing like an airplane ride, which is what most people think it's like. You sit down, you buckle in, you go to space, you come back, and you have it's not like that. It's very dynamic, and a lot of people don't understand what their bodies will go through, which is great because this is what we provide training for. So we put together a program to train civilians. And when I say civilians, these are just non-military personnel who want to buy a ticket to go to space, and actually this can be anybody that wants to participate in space training, but may not want to go to space, but just enjoy the feeling of going through the training process, seeing what being an astronaut for a day is like, and going through the exact same training programs that actual astronauts have gone through.
Mhm.
The training that we provide, we do not change it from the actual training we provide to the SpaceX people, to the Axiom space people, to the hundreds of Virgin Galactic people that we've trained. You will train in the exact same methods that they train. Okay, so uh, I don't know if your viewers know that you're going to be here in about a week and a half to go through your training program, and you've elected to take the 2-day suborbital space flight training for the Virgin Galactic team. You're going to go through the exact same flight program that Richard Branson himself went through. You're going to go through the exact same program that almost 400 of the Virgin Galactic crew and spaceflight participants have gone through. And then when you get finished with my program, you're going to get a training certificate that Virgin Galactic will look at and say, okay, now you're qualified to go fly. Because everybody that flies on Virgin Galactic has to come through NASTAR training, and they have to show their certificate of completion to show that you've been trained, and that puts a check in the box for you to qualify to fly for them. So I got quite a few success stories behind that I can get into later. But that's the NASTAR Center, and that's how we got started. And now we're extremely busy. Just yesterday, we finished training with SpaceX. We trained the Axiom 4 crew, and the mission commander for that is Peggy Whitston. I've known her for a few years. She's come through NASA for a few times, so she's kind of my friend. And very proud to say that, Peggy's been doing great in space, and your viewers may not know this, but Peggy Whitson is a very famous person in the astronaut community. She has more time in space than any
Mhm.
U.S. astronauts out there. So she's got the record for that. That's amazing that she comes to NASAR for her training. So yeah, we're very proud to have done that.
Yeah, so well, speaking about the Axiom crew, so there are lots of private astronauts now. So or there we will have more private astronauts heading to space. So what are the biggest physiological challenges that they might face, and how does NASTAR help them prepare? Or what should I expect when I do my training in a few weeks
Yeah.
probably?
Yeah, NASAR Center is expecting a large growth in the commercial spaceflight training market because we're expecting a lot of astronauts to go to space. And not just astronauts. I'm going to call some of these people space workers.
Mhm.
Blue Origin putting a orbital reef in space, a resort area. Planning to have habitats on the moon. We're planning on having habitats on Mars. There's a lot of space activity going on, and we're going to need to put a lot of people into space. Okay.
Mhm.
And this is what I mean with the term of space workers. Um, Traditionally, most people who have flown to space have been highly trained test pilots, scientists, um, engineers, geologists, people who have gone through a 2-year long training program. And for the commercial space, a lot of people are going to have a very specialized skill, saying, I'm going to put together a habitat. So this is my skill, putting that together. There'll be geologists out there studying rocks
Mhm.
and things like that. There's all kinds of people that need to go to space, need to go to the moon, need to go to Mars. So we're going to need to compress their training program. Uh, NASA takes 2 years to qualify for an astronaut. We don't have that luxury of 2 years time to get people trained. We need to get them trained more quickly and more efficiently and more focused on what they need to do and what they need to know to survive in space, then ultimately get their job accomplished or their mission accomplished when they're in space. Okay. So at NASAR, what we've done is set up programs that focus on the physiology of going to space.
Mhm.
Most of the nuts and bolts work of being in space, putting on a suit, taking off a spacesuit, donning or doffing a suit, emergency systems, that's all going to be provided by the launch provider. Okay. I want to prepare you for the flight dynamics of going to space. Okay. And these dynamics are very different than an airplane ride. Okay. And what you're going to experience in a week and a half here at NASTAR Center are G forces on your body that you've probably never experienced before. And I say these G forces are going to be in multiple vectors on your body, meaning they're coming from different directions. And in one case, it's going to be simultaneously. Okay. If you look at the Virgin Galactic launch profile, the little spaceship gets carried aloft on a mothership. At about 50,000 feet, the spaceship drops. And then it does a horizontal acceleration as the rocket motor ignites and pushes you forward. That's a GX vector. Okay, so you're getting pushed back in your seat very, very hard. Okay, it's a rocket motor behind you. Okay, and then to go to space, it has to make an angular acceleration turn to go vertical. Okay, while it's accelerating. So you're getting a GX force front to back on on your body, and you're getting a GZ vector, which is up and down on your body. And when it makes that angular acceleration turn, you're getting both of those vectors simultaneously. Now, individually, the vectors are not that difficult because they're only going to 3.5 and in some cases 4.3 Gs. So, in itself, that's not a big deal, but together, it does make a big deal. It's very difficult. Okay. So that's why people need to receive training to understand the countermeasures of what happens when you have a GX vector on your body. And it's I call it's like having a baby elephant sitting on your chest. It's very, very difficult to breathe. So we teach you pressure breathing techniques and how to compensate for that weight on your chest. And then on the vertical vector, you're going to have loss of peripheral vision. You could have possible ALOC situations where you have what's called almost loss of consciousness. So we teach you countermeasures to keep your body tightened up, to keep the blood pressure up to your upper torso and head so you don't lose vision and you don't start graying out or things like that, okay?
Mhm.
So that's a different thing. Then putting them both together, uh, it's kind of difficult because you're focused on one, but yet here's another vector coming on. Now you got to put them together. So that's what the training's all about, is to make sure that when you experience these on your actual rocket flight, you're fully prepared. You know what countermeasures to use. You know how intensely that you have to use them. So you've practiced them. There's nothing in the world better than an actual flight than practicing it a few times
Mhm.
so you get the feel of it, and that's what we do. So we focus on the physiology aspects of it here, okay? And then we provide screening to the medical community. Um,
Mhm.
there's a lot of people that have the dream of wanting to fly to space, okay? And one of my trainees, and I'm going to mention him by name because he doesn't
Mhm.
mind, uh, his name is Juan Maggie, okay? He's an
Mhm.
Argentinian citizen who's had polio since he was 1 year old. And he called me on the phone one day. He said, Glenn, I've tried with SpaceX, I've tried with Virgin Galactic, I've tried with Blue Origin, I've asked the Russians, I've asked the Chinese and the Indian, I've asked everybody, can you get me to space? And they all said no.
Mhm.
And he basically was almost begging me to get him into space. I said, look, let me see what I can do. Excuse me. So we set up a program where if he could self-ingress and self-egress from the cockpit, just sitting there going through the profile doesn't take that much strength. It takes upper body strength, which he has. He just doesn't have any strength in his legs. But he was mobile. He was ambulatory using hand crutches. So he came here for training. He got into our cockpit himself, flew through the program, did excellent on the flight training portion of the program, self-egress from there, and I gave him a training certificate. Juan Maggie now has a ticket to fly with Virgin Galactic to go to suborbital space.
Wow, so you're saying that in the near future or in the future we will have a lot of future astronauts who are with disabilities. Is that correct?
Yes, yes. And we
Oh.
just signed an agreement with a company called Astro Access that specializes in people with
Mhm.
minor disabilities, trying to get them into space. So we're going to be working heavily with them in the future. So people that are watching this, if they might have a minor medical, issue with themselves, don't count yourself out.
Mhm.
Okay. Everybody has a chance to go to space. People with minor disabilities can go to space. Okay. That's what we're here for, is to screen you and on safely on the ground to see if you can take the rigors of actually going to space. And that's what the launch providers are going to ask of. If you apply to them for a ticket to go to space or for a job working in space, they're going to say, well, can you actually go to space? We'll send you to NASA for screening to determine that. And here
Mhm.
at NASA, we will do everything we can to get you to space. Okay, that's our goal.
Wow, well, that's really great actually for all the humanity. But is NASTAR also looking into advancements in centrifuge training to help commercial astronauts to better adapt to these extreme conditions? Do you have
Yes,
research
yeah.
on that? Mhm.
Yes, yes, yes. Our parent company, Environmental Tectonics Corporation, has been selling
Mhm.
centrifuges to militaries and organizations
Mm.
around the world for, gosh, over 60 years. I've flown over a dozen different centrifuges all around the world. Um, Now, some of these centrifuges were built back in the 50s and the 60s and the 70s, so they're pretty old right now.
Mhm.
But the technology of centrifuges have increased tremendously within the last 10 years. And the big difference between centrifuges of new versus centrifuges of old is in the positioning technology of positioning the cockpits in certain positions so you can accurately replicate the G vectors of a spaceship or a high performance aircraft like a fighter plane or things like that. The older centrifuges had passive positioning on the gondolas, basically using centrifugal force to position the gondolas. But now with the onset of high performance aircraft like the F-16, the MiG-29, the Sukhoi 27, all these high performance aircraft, they can change vectors or change their position in the sky very, very quickly. Well, if you're going to train in a centrifuge, you need to be able to mimic those exact flight dynamics of that high performance aircraft. So you need to be able to change its vectors very, very quickly. This is where having powered gimbals or powered cockpits come into play. Okay, when you go through the Virgin Galactic flight profile, you're going to receive a GX and a GZ
Mm-hmm.
vector simultaneously. The only way to accomplish that, other than a real spaceship flight, is to put you in a centrifuge of powered gimbals so I can position you in pitch and roll simultaneously to give you those simultaneous vectors. Older centrifuges don't have that technology. So if your audience is saying, well, let me go shopping for space training, and they pick a place to go that has a centrifuge, do some research. Make sure they can provide you with an accurate representation of the flight that you intend to take. Okay. Um, there's a lot of space training people out there that, will put you through an academic program and then put you on an airplane flight, like an aerobatic airplane flight or an
Mm-hmm.
old fighter plane flight. And the issue with that is, I'm a pilot. I love flying airplanes, but it doesn't give you accurate representation of what a
Mm-hmm.
spaceship will do. It's different. It can only give you a G vector in one direction, the GZ. When you see an airplane doing a high bank turn, you're getting a positive GZ vector, which is pushing the person down into their seat. It doesn't give you one front to back also at the same time. Okay.
Mm-hmm.
That's the issue with airplanes and real centrifuges versus rocket ships. Okay. So, and the other thing that trainees need to do if they're out shopping for space training is to find
Mm-hmm.
out if their training program is actually FAA approved. Now,
Mm-hmm.
in different countries, they have their own version of the FAA, but here in America, that's our regulatory agency for aviation and commercial spaceflight training. And they have come to NASA and certified our two pieces of our equipment. One was a high
Mm-hmm.
performance centrifuge that we have that you're going to fly on, and the other one is our high altitude chamber that we're going to use for high altitude balloon flight trainees. Okay. So just make sure that wherever you go, they have some type of government review and approval of that process, and that, because that makes sure that it's a safe environment. Because if things aren't done properly, G-forces can be dangerous. And if you're not taught how to apply the proper countermeasures to those G-forces, this could cause injury to yourselves. Okay, so you've got to be careful of where you go for this training. Okay, make sure it's approved and reviewed by some kind of a government body. Okay.
So
Yeah.
do you know how many facilities are approved by FAA as
Well,
of the
here in
moment?
America,
Mm-hmm.
there are FAA issues many approvals for different types of space things.
Oh,
Like you have approval for space launches, you have approval for rockets, you have approval for launch pads. So you have all these lists of different types of approvals. But for space training, NASTAR is currently the only one in America that has
mm-hmm.
FAA approval for commercial spaceflight training. Okay,
Okay.
there are other people that can apply for academic programs saying, well, we can provide the academics for this. Well,
Mm-hmm.
yeah, a lot of people can do actually can get that off the internet, but to
Mm-hmm.
provide physical, actual,
Mm-hmm.
realistic training, only NASTAR can do that. And what
Oh.
sets what sets us apart from everybody else out there is that we have licenses from SpaceX and we have licenses from Virgin Galactic, and we have their actual flight data from their ships. And we take that information and we model it into our centrifuge. So you get the exact same flight profile that the Virgin Galactic spaceship has, or the SpaceX Dragon, Falcon 9 Dragon combination that has. So we give you the exact same dynamics. There's nobody else other than the launch providers that can do that.
Mm-hmm.
So that's why we're very proud to be able to do that. And we say we provide real training because you're going to fly on that real ship and you get the real dynamics of that flight.
So
Okay.
yeah, well, that sounds exciting actually. So I can't wait to go there and try the centrifuge. But you've been training a lot of private astronauts in the past. So are there any particularly challenging or surprising findings from training private astronauts?
Um, Not really. If you're in relatively good shape, physical
Mm-hmm.
condition, pretty much anybody can go to space. Uh,
Mm-hmm.
but the thing about it is, the number one comment I get from the hundreds of people that I've trained is they didn't think it was going to be like this. They thought it was going to be different. And a lot of them equate this training for space flight to be about the same as training for an airplane flight, but it's not because the flight dynamics are so intense. So, but they're very happy to have come here. Saying, I can't believe I would have gone to space if I hadn't have come here. They're just amazed at the difference, and they appreciate the training they get because now they feel not only more prepared or more confident in themselves to be able to go through this. Okay. We have some people that come here and quite frankly, they're a little bit nervous, okay, for their upcoming flight. But to put them through the flight dynamics and the coaching that we give them, we say, well, look, you just did this 3 times in a row. You're good to go. And they get so enthused and so excited to go now. So that changes their entire perspective on what they're about to go through, from the nervousness of first appearing at NASTAR Center for training to the excitement of actually launching into space. Okay. So
Mhm.
that's a great, personally very satisfying for me to be able to take somebody from that stage of being nervous to being excited to go to space. And you see that light bulb go off in their head, like, wow, I like this. This is going to be fun. It's just exciting for me and my team. Yeah.
Looking ahead, so as the mission extends beyond suborbital flights to long duration space travel, how do you see space flight training evolving in the next decade?
I think that's the next hurdle that the
Mhm.
science and medical community must study and overcome is how do we travel. It takes 9 months to get to Mars, and that's, that's a long time. You know, how are they going to do this if they want to travel light years away to other planets? Okay. How do we break that barrier? How do we get past the speed of light or travel near the speed of light? How do we keep humans alive for, you know, 20, 30 years in space doing a long duration space mission? Is hibernation the answer? There's all kinds of questions that are out there of how do we get to there, but right now, I think the scientists and the medical community all have to work together to start figuring out, yeah, we can't accomplish this, and this is the road to do it. So there's a lot of research still to be done, but I think that's the next big hurdle because we can do short duration space missions. Like going to Mars takes 9 months. Okay, you're 9 months older. It's not a big deal. It takes 9 months to get back home. All right, so you're going to be a year and a half, older, 2 years older by the time you do a round trip. That's doable. Okay. But going to some distant planets and distant stars, or 1 or 2, even just one light year away, that's a long
Yeah.
mission. And how do people survive that? Okay, so that I think is the next big hurdle. I don't think it's insurmountable. I just think it's going to need studying and science and the medical community to figure this out. And once they do, we'll conquer that hurdle.
So I think my personal question actually is so you know that human space program is very expensive for countries. So that's why I actually emailed NASTAR before to ask for how I can train for a space flight. So how do you think commercial space flight can benefit uh, developing countries like us? Or do you
Okay.
think there's a
Yeah.
benefit for this kind of thing from commercial space
Yeah.
flights?
Yeah. Commercial space flight, the way I see it, is
Mm-hmm.
just like the aviation industry 50, 60 years ago.
Mm-hmm.
It was very few. It was very expensive. Uh, yes, they had problems at the beginning getting this thing settled out and figured out. They had to get routes and things planned, all this stuff. And that's where the commercial space industry now. There's talk about point-to-point transportation. There's talk about, supersonic transports, things like that. There's a lot of this going on right now. And I think in another 30 or 40 years, things will settle down. It'll become a commonplace event and point-to-point transportation using suborbital will become a common event. We have airports at cities all around the world. Okay, it's not that hard to change an airport into a spaceport for vertical launch capability or vertical launch recovery. We have recovery on barges out at sea right now with SpaceX landing a booster on a
Mm-hmm.
drone ship. Okay, we can put uh, barges out in harbors next to a city and have a ship land there and have transport into the city from there. So all this is feasible right now. It's just a
Mm-hmm.
matter of letting the industry settle down, starting to figure out, starting to get the reliability to the point where we want it to be safe for commercial spaceflight. And I think point-to-point transportation through space is absolutely
Mm-hmm.
doable. Okay, it's doable pretty much right now with the Virgin Galactic system, taking off from an airport, landing in an airport. You know, we can do that right now pretty much, but now with rockets to do it even within a matter of minutes, it's going to shrink our globe down to where
Mhm.
people can visit each other only
Uh,
minutes away from each other anywhere in the
mhm.
world. So that's where we're going to get to eventually, I think. So
Yeah,
I
so
think it'll benefit almost any country. Um,
mhm,
the Philippine Airlines, they started about 50 years ago or so as a
mhm,
small air. Now they're a big airline. Okay.
mhm.
And same thing will happen with the space program for all countries. They'll start out small and it'll grow big. Okay. Yeah.
Yeah, so on that note, so the emerging space tourism and missions, do you think there's a need for a new NASTAR style facility, or are you looking for, expanding your
Well,
facilities to other?
there are. I believe, NASTAR Center, we kind of have the whole world right now because the whole world's coming to us for training, and that's great. We love that. But I see this as breaking down into space centers, maybe 5 or 6 globally around the world that'll be focused. And of course, the country that has their first space flight center with a space training center, that'll become the first hub within that region. So
Mhm,
it's a great economic benefit to that country. It's a great benefit from a political standpoint and a world recognition standpoint. And
mhm,
like I'm going to use the Philippines, for example. If you took Manila International and you put on a spaceport off to the side of that and made that
mhm,
an international flight and spaceport hub, that would put the Philippines #1 in that entire region.
mhm,
Okay. And this is something that the Philippine government should consider because eventually, with the commercial space growing, these spaceports are going to be needed all around the world. Okay. So
yes,
there,
just like
there
airports.
there's a spaceport. My friend George Neal is running the spaceport society or some organization like that that organizes spaceports for countries. Okay.
Mhm,
And yeah, the Philippines, should have one because with the amount of tourism you have tons of people coming there. But a lot of people don't want to take the long flight from Europe or want to take the long flight from America to get to the Philippines. But with commercial space flight, you could be there in an hour, minutes, things like that. So it would work. And plus, you would have training from all around the surrounding countries. Well, we'll go to the Philippines to do space flight training, and you'll get people from that entire region, Southeast, Asian region to come there. Okay. People in North America will come to NASCAR because we're close. People in South America will go there. People in Africa, Eurasia, they'll all go to about these 5 or 6 different regions. And I think that'll pretty much saturate most of the globe as far as needing to have space flight training centers. Uh, and right now there's only one, that's NASTAR. So there
mhm,
needs to be numbers 2, 3, 4, 5, and maybe 6. So who are they going to be?
mhm,
It's whomever the government has the most interest in and
mhm.
can financially, if you can financially sustain a large airport, you can financially sustain a spaceport training center. So it's not that
So,
big of a reach for the
oh,
governments.
okay. So I thought actually is that you need to invest a lot of resources to build a spaceport. So is it really like investing in an airport?
Hmm.
Mhm,
Yeah. The government should be investing in a spaceport. That's very
mhm,
important, I think, to the longevity of sustaining, I'm going to say the Philippines again, within the global space community. Okay, if they want to be part of the space community and help the country themselves, they should invest in a spaceport. Now, I'm saying this to every country, but I'm a little
mhm.
biased to my home country, the Philippines. But yeah, but every country should consider this. But it's going to boil down to, I think, 5 or 6 around the world. And
I
those
hope
that
so.
miss out on this opportunity, your people in your country want to travel to space, they'll have to go somewhere else near to a nearby spaceport to go. And your home country will miss on that economic opportunity. So, this is a chance to strike, and the chance is now. That's when it needs to be done because it'll take 4 to 5 years to, get the land, get the buildings in place, get the training center set up, get people trained and certified, get your operations certified. So you've got to plan 5 years ahead, and then you're
Mhm.
ready to, turn the key and launch your first rocket or launch your first spaceship 4 to 5 years from now, if you start planning this. So it needs to be done soon. Yeah.
This has been actually an enlightening 30 minutes of our talk. So I think for the last question is, what advice would you give to someone aspiring to become a commercial astronaut today?
It's very simple. The first thing you need to do to aspire to become a commercial astronaut is to have the dream to become an astronaut and use that dream to fuel your activities. Okay.
Mm-hmm.
You start doing research on becoming an astronaut. You maybe go to some analog astronaut training camps. Okay. Then you start coming in for actual training. You need to determine what type of space flight do you want to take? Do you want to take a suborbital one and do some research for a short duration flight? Or do you want to go on an orbital flight to go to the space station and do some research for a month or two on the space station? So you need to figure that out and then tailor your next avenue, your next path to go on that road. And then we'll take you to NASTAR and say, okay, if you're going to go like yourself suborbital, that's what you'll do. You're here for 2 days. If you want to go orbital, you take that program, you're here for a day. If you go orbital, you get a certificate to go on SpaceX. Like yourself, if you go suborbital, you'll get a certificate to go on Virgin Galactic. So you need to figure out what road or path you want to take. And there's a lot of people out there that will help you accomplish that dream of going to space. So, yeah. So it's really open to anybody. And when I say anybody, anybody, and even
Yeah.
those with some minor issues, medical issues. So, yeah. Yeah.
Oh, thank you. So this has been such an insightful discussion. So thank you, Glenn, for sharing your
Yeah.
expertise with us. Before we wrap up, where can our listeners learn more about NASTAR and the work you're doing?
Well, yeah, you can go to our website and find out
Mhm.
more about NASTAR, or if you wish, you can email me directly. And if you allow me to say my email, I'd be happy to
Okay,
give
yeah,
that out.
go
Yeah.
ahead.
It's my initial G, my last name is King, G King together at etcusa.com. Okay. And if you look on the NASTAR website, you'll see my email address on there somewhere. Just feel free to email me if you have any questions. I am going to be at the Space Symposium in Colorado Springs in April. So I'll be wandering around on the trade show floor. If you find me, just say hi and I hope to be at the IAC in Sydney, Australia
Okay.
later on this year. So
Yeah.
you'll find me at different trade shows. Or if you're in the northeast part of the region of America, feel free to pop into NASTAR for a tour. Tours are always free.
Oh, okay. So that's nice. So to our listeners, NASTAR tour is free. So you can probably schedule a tour with
Yeah,
NASTAR. Yeah,
yeah.
right.
Okay.
So thank you again, Glenn.
You're
And to
welcome.
our
I'll see you in about a week and a half.
yeah, see you.
Okay.
I'm very excited to go there. And
Okay.
yeah, for our listeners, stay tuned for more episodes on commercial space and innovation.